now talk about weighted averages, which happens to be the last segment of material for this first section on descriptive statistics. Weighted averages is very similar to calculating averages with frequencies, both for integer frequency data and for interval frequency data. But this also gives a nice segue between the material on descriptive statistics in this section and the probability distributions later on. We use the weights instead of frequencies. And we can think of the weights actually as relative frequencies. So the weights are given as proportions or percentages. The weights must add up to 1. Alright, so we'll denote W as the weight. So the sum of all the weights must always be equal to 1. Okay, otherwise we don't have all the intervals or items represented, and therefore a calculation of an average is a meaningless concept. The calculation for the average is very simple. X bar is just then sigma WX. Alright, if we were doing sort of an analogy between this and the frequency calculation, we would do sigma WX divided by sigma W, but since sigma W is equal to 1, we can do sigma WX divided by 1, and of course that's just equal to sigma WX. Alright, so it's very simple, and you can deal with it is exactly the same way as you deal with frequencies. Let's go through two examples. The first one, let's say that we have an X, which is the number of in want of a better term, up days for a particular stock. During a 5-day trading week. Right, an up day would be a day in which the stock price ended higher than the previous day. So in a 5-day trading week, you could have 5 up days, you could have 0 up days, or anything in between. Alright, so we'll have possible X's as 0, 1, 2, 3, 4, and 5. Alright, so we have integer outcomes here. Let's say that the true weights for each of these occurrences at a particular point in time are as follows: 0.3 or 30%, 0.2 for 20%, etc., 0.2, 0.1, 0.1, 0.1. Okay, we have to be careful, give the representation that our weights add up to 1, and they do here. To calculate the average, we'd have a column for WX. Okay, so 0 times 0.3 is 0, 1 times 0.2 is 0.2, 2 times 0.2 is 0.4, 3 times 0.1, 0.3, 4 times 0.1, 0.4, 5 times 0.1, 0.5, and when you add all those up, you get 1.8. So that's sigma WX, or that's our X bar. So the average, or actually expected number of up days, is 1.8. Okay. Alright, in the next example, use interval data, and let's say again we have our grade distribution. Different numbers are 60 through less than 70, 70 through less than 80, 80 through less than 90, and 90 through 100. And let's say the weights here are 0.2, 20%, 0.3, 30%, and B's and A's both 25%. Okay, so again, we have our weights adding up to 100. The X's, just like regular interval data, will be the midpoints: 65, 75, 85, 95, and to calculate the average or expected grade, we get WX. First is 13, 22.5 for the next, 21.25, and 23.75. Alright, and those add up to 80.5. So 80.5 is our sigma WX, and is also our average or expected grade. We talk about expected because these are now weights or probabilities, and it's not an average for a sample. It's sort of an average for a global concept, and therefore we quite often call this the expected value. Okay, so the expected grade given those probabilities or weights is 80.5. Alright, and that's all there is for weighted average.